Want to unlock the secrets of deep learning? These insights will blow your mind. Welcome to TechEnvisionAI. If you're passionate about artificial intelligence and deep learning, hit that subscribe button and let's dive into some secrets that you won't find in textbooks. Deep learning is at the forefront of AI innovation, but there are hidden aspects that aren't widely discussed. Today, we'll explore these deep learning secrets and how they can revolutionize your understanding. Alright, so you want to dive into the world of deep learning? First things first, we got to understand the foundation, the building blocks, neural networks. Think of them as the engine under the hood of a self-driving car, the brains behind the operation. These neural networks mimic the way our human brain processes information. We're talking layers upon layers of interconnected nodes, like a complex web of neurons firing signals back and forth. Each connection between these nodes has a weight, determining how strong the signal is. As the network processes data, these weights are constantly being adjusted. That's the learning part. These networks can handle complex data, images, text, audio, you name it. They can pick out patterns and make sense of information in ways that traditional algorithms just can't match. We've got our neural networks all set up, ready to learn, but they're only as good as the data we feed them. That's where data pre-processing comes in. This crucial step is all about cleaning, transforming, and preparing our data. Techniques like normalization bring our data onto a common scale, ensuring no single feature dominates the learning process. Data augmentation artificially increases the size of our training data by creating slightly modified copies. Dimensionality reduction simplifies our data by reducing the number of features while preserving its essential information. Trust me, investing time in data pre-processing is crucial. It can make all the difference between a model that performs poorly and one that truly shines. It's like condensing a lengthy paragraph into a concise sentence, getting straight to the point. Now let's talk architecture, the blueprint of our neural networks. Just like there's no one-size-fits-all smartphone, there's no single neural network architecture that reigns supreme. The key is to choose the right tool for the job, an architecture that aligns perfectly with the type of data we're dealing with and the task we're trying to accomplish. For images, convolutional neural networks, CNNs, are our go-to. For sequences of data, like natural language processing or speech recognition, recurrent neural networks, RNNs, step up to the plate. And then we have transformer networks, which excel at capturing long-range dependencies in data. Choosing the right architecture is like selecting the right lens for a camera. It can drastically affect the clarity and focus of our results. It's all about matching the right tool to the task at hand. Chapter 4. Leveraging Transfer Learning. Training deep learning models from scratch can be time-consuming and resource-intensive. But what if we could take a shortcut, leverage the work that's already been done? That's the beauty of transfer learning, a technique that's all about efficiency and leveraging pre-trained models. Imagine a neural network already trained on a massive data set of images, learning to recognize a wide range of objects. We can take that pre-trained model and fine-tune it for our specific task, say, identifying different types of flowers. Transfer learning is a game changer, especially when we're dealing with limited data or computational resources. It allows us to achieve impressive results with faster training times, democratizing the power of deep learning. Chapter 5. Mastering Hyperparameter Tuning. We've got our data, our architecture, and maybe even a pre-trained model ready to go. But here's where things get a little more technical: hyperparameter tuning. Think of hyperparameters as the settings and knobs that control the learning process of our model. We're talking about things like the learning rate, which determines how big of a step the model takes with each update. Set it too high, and we might overshoot the optimal values. Set it too low, and training might take forever. Then there's the batch size, which controls how much data the model processes at once. Finding the optimal hyperparameters is like solving a puzzle, experimenting with different combinations to see what yields the best results. Luckily, we've got tools like grid search and random search to help us navigate this space efficiently. Chapter 6. Avoiding overfitting. Overfitting occurs when our model becomes too familiar with the training data, learning the patterns and noise so well that it struggles to generalize to new unseen data. It's like a student who can recite the textbook word for word, but can't apply the concepts to solve new problems. To combat overfitting, we've got a few tricks up our sleeves. One powerful technique is dropout, where we randomly drop out or deactivate a certain percentage of neurons during training. This forces the network to learn more robust and generalizable features. Regularization adds a penalty to the model's complexity, discouraging it from learning overly specific patterns in the training data. And then we have cross-validation, a technique where we split our data into multiple folds, using some for training and others for evaluation. This helps us get a more reliable estimate of how well our model will perform on unseen data. It's like telling the student, hey, focus on understanding the core concepts, not just memorizing every single fact. Chapter 7: Real-World Applications. Deep learning isn't just some abstract concept confined to research labs, it's transforming industries and impacting our daily lives in profound ways. In healthcare, deep learning algorithms are analyzing medical images with remarkable accuracy, assisting doctors in diagnosing diseases earlier and more precisely. The finance industry is being revolutionized by deep learning models that can analyze market trends, assess risk, and even automate trading decisions with lightning speed. And let's not forget about the automotive industry, where self-driving cars are rapidly becoming a reality, thanks in large part to deep learning. The possibilities are truly endless. From personalized recommendations on streaming platforms to virtual assistants that understand our natural language, deep learning is shaping the future in ways we're only beginning to imagine. These are just a few secrets of deep learning that can elevate your AI projects. The key is to keep experimenting and learning. Now, as promised, here's the special surprise. For those who watch till the end, you can claim $300 worth of 5 financial calculators for free. Just subscribe, send a screenshot to 911321187 on WhatsApp, and they're yours. If you're looking to automate your stock market trades without coding, check out our How to Automate Stock Market Trades Without Coding. Of course, it's worth $100, but for a limited time, it's available for only $1.20. Don't miss out on this incredible offer. Click the link below to enroll now. And remember, subscribing to TechEnvisionAI means you're always up to date with the latest in AI and technology.